Again, good morning, good afternoon, everybody. This is the review session for the Jan round of the bronze contest for USACO 2021. Thank you, good afternoon. For those who have taken the Jan round contest, you might have felt it is maybe easier than before, than the December round. That is actually the feedback I got from many students. Okay, it is morning. I mean, it is afternoon my side. Probably in from the West Coast, it's still in the morning. All right, so today we're going to review those 3 questions at the bronze level. It is our anticipation, or it is our plan for every round. We would provide the review, but keep in mind some of the techniques that we will use in the review you may not be familiar if you have not gone through the full course training, but don't worry, that'll be fine. In the spring semester, we're going to cover all the details, all the techniques that we're going to use in the bronze level. Actually, we're going to provide a smooth transition from the bronze to the silver level. Some of you in the Jan round and Feb and March rounds, you might have been promoted, or say like this one, right? This time I got very close to 750, maybe 733. Well, if I got one more case, then I would be promoted, but I was not lucky. I did not pass enough cases. So don't worry, you should be all right. For those who have been promoted or those who have not been promoted but close to get the threshold, the promotion line, you're going to both benefit from the spring cluster and the spring semester classes. We have observed the difficulty level that has been steadily going up. So a lot of students have participated, and the number of the people who can get promoted, right, would be limited. So the percentage of people who cannot get promoted, right, of course, would be higher than before. So don't worry, you're going to keep working hard. Every season you have the 4 chances to get promotion. So make a plan. If you want to get the promotion, say this season, 2021 through 2022, you still have 2 more chances. Of course, in the spring semester, probably would be a little bit harder because the March round or the US Open round would be harder because you have 5 hours. And then now it's getting more competitive with other Olympiad subject tests. Right now, math is coming up actually next week, physics, chemistry, and so on. So should be more for the time management. You would have to be more careful to arrange the time from your busy study schedule. So it is our suggestion right before the contest, try to calm down and warm up. Hopefully you'll be the best status going into the contest. Actually, this round, the Jan round, quite several students respond to saying, okay, I did take the suggestion. I did not take the contest on Friday or Saturday. Rather, I took it on Sunday or even Monday. Anyway, in US, you can take the contest on Monday. The deadline is actually 5 a.m. Central Time. So you're not in a hurry. You don't have to do it on Friday. So for many, that works. So hopefully it will be helpful for you. So just find out a good time that you're going to do, you think you're going to do the best. All right, so we're going to go through the 3 questions in order. The first one is the hurdle. Okay, let me move this one to the left. Okay, refresh your memory. We're going to have 2 3 by 3 grids. One is the correct grid. One is the guess. So the first one, 3 by 3, that's the correct grid. And then the next 3 by 3 grid is the guess. And we want to report the number of the letters that are in the right positions, and also the number of the letters that are not in the right positions but have appeared in the correct grid. So look at this one here. This O, the O at the bottom column row here is in the right position. So here, the answer for green, that's 1. And this I, right? Actually, we have 3 copies of I's in the guess, but none of them appeared in the correct, so it does not count. T does not count. H, E, N, the same, because they do not appear in the correct grid, so they don't count for either green or yellow. The only one that could count for the yellow is this W. W does appear in the correct grid, but it's not in the right position. So we're gonna have 1 yellow, means 1 letter has appeared in the grid, but it's not at the right position. So for this question, probably is easier to start from the green count. We're gonna go through each position, the 3 by 3 from the grid, correct grid, and also the guess grid. If they do agree at any position, we're going to increase the green count by 1. And then for those who are not in the same position, so for those that agree, forget about it, right? Don't mess up with the yellow count. Only for those that do not agree, that would be eligible for the yellow count. So that will make life easier, right? So for this sample input, cross this one here as if that one does not exist. That position does not exist because they agree. That should be counted toward the green answer. Now we're going to have a count. So count 1, that would be the number of letters that have appeared. Well, the frequency of each letter that has appeared in the grid, correct grid, and count 2, that would be the number of the times each letter has appeared in the guess grid. Remember, right, when we do the count 1, count 2 here, ignore the letters that agree. That means they're in the same positions. Okay, now for each letter, we're going to compare the smaller one of the 2. So here for letter A, if you have, say, 2 copies here have appeared in the correct matrix, but 3 copies have appeared in the guess, then, you know, right, 2 of them should be reported, should be counted to the yellow answer. Similarly, if you have, say, 4 copies here, but only 3 copies here, then only 3 should be counted toward the yellow answer. So in a sense, right, we're going to find out the smaller one of the 2 numbers and add this one to the yellow answer. So it's possible this one has 4 copies, but this one is 0, then 0 should be added to the yellow answer. So basically we're going to take 2 arrays, both have size 26. For each position, we're going to find the smaller one of the 2, excuse me, and add it to the yellow total answer. And then that would be the way to solve the question. So for this one, I would write the answers. So if you want, you can also work with me. And I try to pause so you can follow me. Okay, so let's do it together. I have it here. Actually, I have the code here, so I'm going to write one more time. So here, hurdle say 0. Import the java.util.star and scanner in system.in. And we're going to read actually the 2 grids. So here I'm going to do character. That's the correct. That'll be 3 by 3. And we're going to read this one here, row. That's 3 correct. At R should be in dot next and then to character array. And I'm going to do this one for this guess. The same. So guess at R and C here also should be this to character array. So basically I'm done with this. I can close the input. Oh, I'm sorry. This one should be just R here. So this one I'm going to read one row here. This row I'm going to convert into a character array. So I don't have to do the assignment. Guess R and 0 and 1 and 2, right? So that would make a little bit easier. Why don't I use buffered reader? Good question. For Browns, normally we say we're going to use the scanner. Why? Because the amount of the data to be read from the input is minimum, right? So here you only read the 3 by 6, I mean 6 by 3 matrix. So it's minimal. So making the using the scanner or using the buffer reader actually does not make any difference. But you're right. When we go to the silver level, then input size normally would be much bigger. So n could go to 10.5. And using the scanner and using the buffer reader could make a difference. Sometimes the difference can go 0.3, 0.4 seconds. Don't think that's a small amount. Sometimes that 400 milliseconds could make a difference. Oh, Alex, we're working on question 1 in the Jan round, the hurdle problem. Good. Okay. Good. Okay. If you have any questions, please stop me anytime. Okay. Is it possible to qualify for gold in 2 months? Probably not that easy. Of course, right? There's always the intersection. If you work so hard and so dedicated, maybe you can get promoted in 2 months, but not in a hurry. Why you need to get the promotion to gold in 2 months? I don't think there's any specific reason. Oh, that's fine, because you still have the chance in the December round of 2022. That's still that'll still be I mean, within the time frame for your college application. Why do we use car instead of string? Well, because later I want to do the comparison at each location. So I want to do the correct row R and the column C. Guess row R and the column C. You can do the string, but then you're going to do the character add, right? So that would be a little bit messy. So I want to make them as a 2-dimensional array of characters rather than 1-dimensional array of strings. Okay, you're going to see in a moment how I say this one. So I'm going to have the count, right? So this is the green. That's the yellow. The 2 count, that's the answer for the green count, the yellow count that we're going to print at the end. So at the end, we're going to have this green plus new line and also the yellow. Okay, hope this this is the plan, right? I want to count the places for the matched letters at the same location, the same letter. And also yellow, they appear, but they have not been the right positions. Okay, so I'm going to have the frequency. So frequency 1, that's from the correct matrix. So this one should be 26. And frequency 2, that's also 26. Now I'm going to do this one. Oh, sorry. R goes from 0, R less than 3, R plus plus. C goes from C, C less than 3, C also goes up by 1 here. So if the correct R and C is equal to guess R and C here, that should be obvious, right? We should increase the green by 1. This one should not be bothered to consider the frequency 1 and 2. They should not be messed up. Only when they're not the same. When they're not the same at the same I mean the position RC, right? Correct and guess they are different. Then those letters should be eligible for the count for yellow. So here I'm going to say frequency 1. This is guess, right? I'm going to say correct at R and C here. This is a letter, a character. So cannot use this one for the index. Even though this is the part I highlighted, right, is an integer. You can use it, but that's not the one we want. Actually, we want to have the index in the alphabet, right? Because I have created this one. The two arrays, frequency 1, frequency 2, they have sizes 26. So I need to get the index in the alphabet. So I'm going to do the -a, the character minus another character. This is done using the ASCII integers. And the result is the index of the corresponding letter in the alphabet. So this should increase by 1, right? For this particular letter, the frequency has increased by 1, and do the same thing for frequency 2. So this is guess RC, and also -a also increase the frequency by 1. Okay, so after this loop, we have updated the frequency for each of the 26 letters, whether they have, how many times they have occurred in the correct matrix, and how many times they have occurred or appeared in the guess matrix. Now, green is already done. Now I need to have the yellow. So yellow, I'm going to say letter, I'm going to use X here, goes from 0, X less than 26. As we just said, right, we're going to say compare the frequency at X and frequency 1 and X and frequency 2 and X. So I'm going to do the yellow. Actually, should it be increased by the smaller of the two? So this would be frequency 1 at X, frequency 2 at X. And then that's the total count for the yellow. Each letter, depending on how many times have occurred in the correct matrix and how many times occurred in the guess matrix, take the smaller one and add it to the yellow count. So that has taken care of all the 26 letters, not just one. All right, so hope this is clear. All right, so let's run the sample test case. The sample test case, let me do this one here. And there'll be 1 and 1 here. And I should have the test data ready. Yes, I do. So I'm going to run this one here. Let's go to that's 4. Then I have this one. I just created, right, hurdle 0. So hurdle So 0. And we'll just try every test case, and I'm going to check that is correct. All right, okay, so this one should be clear, right? Not too complicated. Comparing to the questions in the December round, this one is, I think, would be much easier, right? Many of you, after reading the question, say, okay, yeah, I know what to do. I understand. So that will give you the confidence. So for most of you, could figure out the first one within, say, maybe 30 minutes, 40 minutes, and that will make your life much easier. Okay, any question? Okay. What does the else do on 25? Oh, 925, because the two letters, right, at the same location, at the same position, the two matrices, right, if they agree, that's a green count. If they don't, that should be eligible for the yellow count. Good, okay. Okay, good. Okay, I'll be happy to answer the questions, right? What does the this one minus A do? If you were in the full semester, right? You have seen this before. We have talked about. Let me go through this one more time. Yeah, 9, 26, 27. So here, this is a letter, right? Correct is a matrix here, two-dimensional array, 3 rows, 3 columns. So if I take the character at position R and column C here, that will give me a character. This character would be all uppercase letters I read from the input. And I want to get the index in the alphabet. So if you do say A minus A, this will give me 0. If you do B minus A, this will give me 1, and so on. C minus A here, this will give me 2, until if you do Z minus A here, that will give me 25. Okay, hope I've answered that question. Why we're going to do the minus the letter A. I want to get the index in the alphabet. So if the index is 1, I know that's letter B. Index 2, that's letter C. Good. And also, why don't we use array list? That's a good question. Where do you think we can use array list? And you feel that is more appropriate than using arrays? Okay, here, let me say right here, if you know the dimension at the very beginning, right, then it's better to use arrays. Why? The syntax still would be better, right? So you just use the square brackets rather than using the dot get. So I prefer to use the square brackets because I don't want to type the whole thing, dot get. And then especially the last one is kind of awkward. But anyway, the two are in this, basically the same thing. Array lists and arrays, they are the same. In Java, array lists are implemented using arrays, so they still enjoy the same benefit, the cross proximity. So that will make the access time short. Okay, why do we use math.min to find yellow? So if letter A has appeared, right, so A, B, C, D, E, F, G, H, I here, that's the correct matrix. And here the guess, even though you have, say, appeared 3 times, and say 2 times here, so X, Y, Z, W, S, T here, right? So here you have 1 A, but you have here I have 2 A's. but you should not count 2 copies of the ace as yellow. Only one of them should be counted as yellow, right? So you take the smaller one of the 2 counts. Very good. And specifically, right, if there is no A, this one is also B. So even though you have 2 copies of A's, but there is no A in the correct matrix, then that contribution of A should be 0. So we're going to take the small one of the 2 frequencies added to yellow. All right. Very good. How do you increase your problem solving skills? Well, I know this is cliche, but it is true. Practice, practice, and practice. This is actually very similar to the Olympics. Well, the Winter Olympics, right, is going on. So the same thing. Even though you're talented, you have the gift, right, you still have to practice. All the Olympics shared one common feature. This is one of them, right? So you need to practice. The same thing. If you say you're good at violin, do you think you need to practice, or you say I have the talent, I don't have to practice? No, you still have to. So the same thing. How do you increase your skills level? Well, do it every day. For bronze, that's what we would say, right? Every day, on average, probably 30 minutes. And if you want to get promoted, say silver, gold, platinum, then the number of the hours should increase. Actually, on average, if you want to get to platinum, then on daily basis, about 2 hours. And some say, right, I don't need 2 hours. That's fine. Yeah, if you're talented, you're lucky, right? Maybe you spend on average maybe an hour and a half on daily basis, or sometimes even say 1 hour. That's possible. I've seen that. But still, if you want to qualify for high level, then in general, more time spent. 927, 20. Oh, this plus plus just want to increase the counter by 1, right? I've seen this letter here in the position R and C, right? Then I'm going to say increase the frequency by 1. So plus plus means increase the count by 1, or increase the frequency by 1. Okay, so make sense? Good. Okay, so nice. I like this way, and you can participate. Actually, for the for the spring semester and also the subsequent training, we have also made changes, adapted our design. We want to have more hands-on experience, and we're going to, rather than giving you, say, 5, 6 homework problems in each week, right? You say, I'm scared, I don't want to do. So probably I'm going to just give you maybe 2 questions each week, but we're going to ask you to submit your solutions and actually do it, not just listening or seeing me doing it, or sometimes the TA will do it, right? Seeing is always easier than doing it by yourself. So how do you feel more confident? Just do it. All right, so that's for the first one. Okay, let's move on to the next. The second question. Yeah, I know some of you, right, are saying, okay, the first 2, I think I'm confident, or I'm not so scared. Third one, I could not figure it out. Okay, let's do it. The second one is the non-transitive dice. Okay, this one, it may take you a little while to understand what it says. So here, basically, you have 2 dice here. One dice is here, another dice is here. It asks, can you find out, so this is die A, this is die B, and you want to find out the die C here, so that it's not the case one die will beat the other 2. It's always, if A beats B, then A will lose to C. If A beats C here, then A will lose to B here. So this is similar like the rock, paper, scissors. So when we say beat, so here A and B in this case, we say A beats B. Why? Let's do this one here. 4, 5, 6, and 7. And B is 2, 4, 5, and 10. For A here, B here. Okay, randomly, we're going to pick one number from A and pick a number from B and see how, what is the chance that A would beat B. If the chance for A beat B is higher, well, if the randomly pick a number right from A and pick a number from B, if the chance is bigger than 0.5, then we say A beats B. Okay, let's see. What is chance for A to beat B here? If you pick a random number from A and random number from B, how many combinations do we have? We have 4 choices here, 4 choices here. So we have 36 here, right? We're going to see how many times the number you picked from A would be the number you picked from B here. So the choice, the combination, right? 4, 1, that's once. That's the only one, right? 4, 4, 4, 5, 4, 10, 8 does not win. But for 5, you can have 5, 2, 5, 4, that will win, right? Plus 2 here. 6, you're going to do 1, 2, 3. 7, you're going to do the same, 1, 2, 3 here. So that would be 8 and 9. So the chance for A to win would be 9 over 36. Let's do the same thing. We're going to try, say, pick a number A, pick a number from B and pick a number from A, right? See how often B would beat A here. If you pick 2 from B, there's no way to beat any number from A, right? Pick a number from, pick the number 4, still there is no chance. Oh, I'm sorry, this 16, you're right, thank you. Now, if you pick 5, then you have one chance, that is 5, 4 here. Nothing else, right? Now, if you pick 10, all of them would work. So this would be 1 plus 5. So that would be 6 over 36, 16, I'm sorry. So this probability, right, is bigger than this probability. So we say A beats B. So here from the description, we say, oh, come on here. We say die X beats die Y if it's more likely that X will win in Y. So more likely, that means the chance here is higher than the chance here. Okay, after this is clear, then we're going to try to answer the question. So for each subtest case here, for each question, and for each test case, we have T subtest cases. For each subtest case, we're going to find out whether there is a C here, so that we're going to do A beats B, B beats C here, C beats A, or A beats B, C beats B, and B beats A. So anyway, we're going to form a cycle. So A, B, and C. If A is bigger than B, B is bigger than C, and C is bigger than A, or opposite. So this is clockwise, counterclockwise, and then also there is another one, the clockwise. So A beats C here, C beats B, and B beats A. So either the blue cycle or the green cycle, either way is fine to make this one intransitive. Oh, I'm sorry. Thank you, Alex. This is 4, so that'll be 5. Anyway, it does not change. Thank you. Yeah, so this would be 9 over 16 bigger than 5 over 16. Thank you. Okay, so now the question is, for every sub-test case, the answer depends on whether you can find such a C, so that either the blue cycle or the green cycle exists. Is that works, that holds. Okay, this one again, not too bad. Why? Because the numbers are rather small, right? all the integers appeared in A or B or C. They should be in 1 through 10. All the numbers are in 1 through 10. So how many choices for each, for the dice C? You have 4 numbers, each is 1 from 10. So there is 10 choices here, 10 choices here, 10 here, and 10 here. So Adam, that's 10 to the power 4, right? Okay, so we're going to try the 10,000 choices for C. For each C, we're going to check if A beats B. Do we have a C so that B beats C and C beats A? If B beats A, we're going to try whether there is a C, right? So that A beats C and C beats B. Okay, so for this 10,000 choices, right, we're going to try either there's C so that B, C, C, A, or A, C, C, B. So we're going to do this one, the comparison. Comparison, we're going to see, right, how many times it does take to check if you have the numbers B, C, whether B will be the C or C will be the B, right? Actually, we have seen, right, this one actually would be 16 times. And you're going to do twice times 2 here. That's number of the comparisons you need to do. That's for each subtest case. And then T is at most 10. So this one is 3.2 times 10 to the power of 6. Yes, you're right, actually. If you want to generate the numbers, you mean you want to check whether the C works, right? Don't use a random number generator. You're going to actually check all the possibilities. Anyway, there are only 10,000 of them. Okay, so here each T is at most 10. This one here, right? So we're going to do this one. For the 10 test cases, each one we're going to do 10,000 times 16, right? There are 16 choices. And times 2, you're going to do the B to C, C to A. Well, actually, you're going to do another one. Depending on A beats B. If A beats B, you're going to do this. If B beats A, you're going to do this. So you're going to do another one. So times 3 here. That's fine. So this would be 4.8 rather than 3.2. That's still much smaller, less than 10.9 here. So if you do this way, you would not have the issue that you had in the December round where time becomes an issue. Right, some of you got the timed out error, the TLE, time limit exceeded. But for this one, the question has been designed, probably has been redesigned after December round contest. So when the numbers are getting bigger, for example, right, this one is not from 1 to 10, rather from 1 to 100, then this approach does not work. Because each one is 100, right? Times 4, that's already 10 to the power of 8, times another 10, times another, say, 48, that's bigger than 10.9. Then you have to do it in a better way. So hopefully this will give us the hope, right? Sometimes a round is more competitive, harder. Maybe the next round, you're going to find your luck. Okay, so we're going to, if it's greater than 100, yeah, just up to 100. So what do you think? The comparison would be, you have to do more efficient. Now we're going to make it, since we have the luxury, we're going to do the 4x4, 16. Actually, you could bring down the factor. Bring down the number of operations by a factor of 4. Okay, so let's try this one here. We're going to, for this one, we're going to, again, build step by step. Okay, maybe a little bit more complicated than question 1, but still is manageable. Okay, so let's try, again, try here. Dice 0, and I'm going to, okay, that's fine. And use this one here. Oh, this is the template, right? Many of you have seen this before, so don't be surprised. So here we're going to read T, that is the number of sub test cases. Okay, and I'm going to this one, say T goes from 0, T less than T here, T plus plus. Actually, this T does not go into the calculation. It just run this T, uppercase T times. All right, so each time we're going to read the die A and die B. So we're going to put them into, should be here. Okay, so I'm going to put this one into 2 arrays. Okay, read them. This bj goes from 0, j less than 4, a j. Oops. bj, that is okay. So we have read the A and B. Now we're going to find out, right? If A beats B, find a C so that B beats C and C beats A here. If B beats A here, then find a C so that B beats A beats C, C beats B, and then B will beat A. Okay, so first let's find write a function whether a die A will beat die B. So here static. Why we want to make a static? Because the function later will be used in the main function. Main has been declared static, then this function also would be static. And this would be Boolean because we're going to say whether A beats B. So beat, this is array A and this is array B here. So we're going to return. So for simplicity, I'm going to say return true. So whether die A beats die B here. Okay, I'm going to have the function put it here, and later we're going to come back and then solve it. Okay, so here, if beat A and B here, the else would be B beats A, right? So I'm going to say, put it here. Oops. Okay. Okay, so now we're going to find out whether there is a C so that B would be C here and C would be A here. Right, you're right. So let's do this one, right? Else, if you make it this way, right? So beat B and A, you're right. Could be the case when they are the same, then you don't need to even try it. Good, okay, thank you. Okay, so now if A beats B, I want to find out a C, right? So how do you get the C? So we're going to say find a C. Okay, so have another function. I'm going to collapse this one. I'll come back. Okay, static Boolean, find C. Again, I'm going to return true. So the idea is, can I find whether C exists so that A beats B? I'm going to do this one. So A beats B, B beats C, C beats A. And the next time if I do this one, I'm going to say use the if B beats A, I want to find C, I'm going to say find B and A here. Okay, so here, if we can find C here, A and B, then we'll just print yes, right? And if we can't, then say no. Because A has shown, right, A beats B here, but you cannot find out a C so that B beats C and C beats A, then there's no way. The same thing here, if find C, B and A here, yes, else no. All right, so hopefully the structure, right, the skeleton should be clear. Okay, any comment, any question? So far, so good, right? So the idea, if A beats B, we're going to find out C so that B beats C, C beats A there. And otherwise, if B is shown to beat A, then we're going to find out A so that find a C so that C would be between A and B in this way. Okay, so let's go into the details here. How do you know whether A beats B? The count 1, that's how many times A would be bigger than B. Count 2, that's how many times B would be bigger than A. So try, I'm going to do say X goes from 0, X less than, I know the array right size is 4. I don't have to make it, Y goes from 0, Y less than 4, Y plus plus. So I'm compare AX versus BY here. Okay, if AX is bigger than BY here, count 1 will increase by 1. AX is less than BY, count 2 will increase by 1. And I do have omitted one chance, one case, right? What if AX and BY are the same? I don't need it because that will not count as win for neither side, right? Okay, now this return statement should be modified whether count 1 is bigger than count 2, because they would be divided by the same denominator, 16. I mean, 4 by 4, 4 times 4, that's 16. So how many times the AX would be bigger than BY, that's count 1. How many times BY would be bigger than AX, that's count 2. So for A to beat B, count 1 should be bigger than count 2. All right, okay, so this one is not too bad, right? Find out a, check whether A would beat B. All right, so no question. We'll go into the next helper function, find a C. Okay, find a C. How do we do this one? As we just mentioned, right, we're going to try all the combinations. C0, C1, C2, C3, C4. Okay, we're going to try this one. So int C, that is, actually, no, I don't have to. So position, say J1 goes from 0, actually going from 1. the four numbers. J2 goes from 1, J2 less than equal to 10, J2 plus plus. J3 starts from 1, J3 less than or equal to 10 plus plus. J4 starts from 1 here, J4 less than or equal to 10, J4 plus plus. Okay, and we're going to do this one here. So int C, that would be J1, J2, J3, J4. Okay, so I have taken all the considerations of the four positions, four numbers in this dice C. Now what I need to do is I'm going to find out if beat C would, B would beat C here, because right, when we go this way here, we're going to say A beats B. What I need to do to confirm, right, is B beats C and C beats A. Beat C and A here, then you're going to return true. If there's no at the end, right, I'm going to return false. Actually, does not make it more efficient if you generate all possible C's and then store them. Actually, storing them would be less efficient than just running this on the fly. Okay, notice, right? So when you call the function, I assume A beats B. But if you already have, say, test right, B beats A, then you're going to do the B first and an A, because I want to always find a C so that this C will, the second one will be the C, and then C will be the first one. So here, if I do this one right, I'm going to find out a C so that the second one, which is B, which is A here, A would be C, and then C would be the first one. Why it does not like test cases? Add it. Okay, let's see whether this works. Let's still try the test cases here. The sample. Okay, let me put this to the left side and run it. Whoops. Is it yes, no, no? It is true, but the printout was kind of doing a better way. I want to get this. Okay, hopefully that's the, it did not finish reading. Okay, kind of weird. Okay, this time is right. If you don't have that new line and it just display weird, and this is the yes, no, no. Okay, there was a question. Okay. Why is the input of the function? Good, okay. So how would you, I don't want to repeat the functions, right? Like this one, A beats B, B beats A here. I'm gonna call this one multiple times, and inside the function find C, I also would call the function beat, find C, right? Beats BC, beats CA here. So I'm going to call the function multiple times, then makes sense for me to put this one into a function. So I'll just call the function rather than repeat the code here, right? If I have to repeat here and repeat here, and also repeat here and here, right? So it makes more sense, put them into a function. And then the function, how do you pass the die A and die B to the function, I think it makes sense, right, to represent each die using an array of size 4. Okay, imagine, right, if you don't do this way, how would you do it? Make sense? All right, okay, so let's see whether this will work for each test case there. We're gonna do this one. That's 5. Oops. Dice 0 here. Okay, they're all the same. And if you notice my type, right, for each test case, I have say x dot input, that's the input side, input data, and then x dot out, that's correct answer. And then this out 2, that's the result we just generated. So here type, say test data and say 07 dot out. This one here out 2. So you're going to write a either a utility function, right, with either in say Java or Python or C++, anyway you want to write, and then just call it. So I'm going to run this in a batch mode, so I don't have to check one by one. Okay, how did you change output format? Are you saying rather than print to the console or print to the file? Is that you're asking? In the old USACO contests, the input you're going to read from a file, and then the output you're also going to write to a file. From last season, this has changed. We're going to read from the standard input, so you're going to have the system.in, and you can also write to this. You can also write to the console. So, oh, that's a different question. As I showed, right, so here you need to have the this one, add a new empty line at the end, then the print would be aligned. Right, add a new empty line after this last integer, then the output should be aligned. All right, okay, so let's take a little break. When we come back, we're going to focus working on question 3. Many of you thought, okay, question 3 is actually the challenge among the 3. The first 2 actually not too bad, right? Okay, so let's take a 5-minute break. All right, let's come back to question 3. Question 3, can it be solved using a greedy approach? Actually, yes, it can be solved using a greedy approach. Let's go back to the description. Okay, question 3, again, refresh your memory. We have, again, sub-test cases here. Each one has T, that's the sub-cases here, up to 100. Each time, we're going to read n numbers. N could be a number from 1 through 10.5. So I know for many students, once you read this part, you got kind of scared. And also the numbers in the array, right? And numbers, each number can go up to 1 billion. So this is the scary part. But actually, it's not that bad. Question asks whether we can to bring down all the numbers down to the same level. So here, for example, this subtest case, 8, 10, and 5 here. What you can do is you can only do the lowering in pairs. So 8 and 10, you can bring down. If you want to make all of them the same, right, you can bring them down. So you can put a 7 and a 9, and this one will still remain 5. So that's one time. And you can bring them down further. So that'd be 6 and 8. So that's the second time. And doing one more time. So that would be 5 and 7 and 5. So that's already 3 times. Each time the cost will be 2 because right, you're going to bring this down to 1. This will bring down to 1. So when we have the final count, we're going to multiply by 2. That will be the answer here. Okay, that's still not enough because these 2 5s are the same, but this one is not. So it's not level yet. What can we do? You can try this one here. You can bring this, basically, right? You're going to bring this down to some number, this down to some number, right? And this one you're going to bring twice. So since this one is divided by 2, so you're going to apply, say, down x here. This one you're going to down by 2x, right? Because x is down here, x down here, right? So this one should be be decreased twice. So this one is, the difference is 2. So you're going to say we're going to bring this down by twice here. This will be 4 times. So this will be also 3, and this will be 3. So you're going to do another 2 times. So this would be 2 times here, 2 times here, that's 4. So 3 plus 4, that's 7 here total. Bring 5 down to 3, that's 2 times here. Bring this 5 down to 3, that's also 2 times. And in the middle, right, when you do apply to this one will be affected. Apply to this one here, this middle one also would be affected. So you're going to bring down 4 times. Each time the cost is 2. So times 2 here, the answer is 14. This is possible. Sometimes this is not possible. For example, this one is, say, 0. This one is 3. This one is 0. There is no way for you to bring down and also remain non-negative. In the meantime, the non-negative to the same non-negative Hangul levels. So actually, this one is impossible anyway, but 0, 2 is actually you can, right? 0, 2, 0. You can bring down to -2 and -2, -2. So that's fine, but we cannot have negative numbers anyway. So when you have some numbers already 0, but the others are not 0, then you cannot do it. Okay, so for each one, we can answer the question, if it's possible, what is the minimum number of the steps to bring down the numbers to the same level? If it's impossible, print -1. So as I said, right, sometimes you might be scared, but this one actually is not that bad. So there are 15 test cases here. The first 8, H is actually at most 100, N also at most 100. So this actually, you should do this one in your contest. So suppose you have done the first 2 questions, right? Question 1, question 2, you get 4 credit. So 2 out of 2 plus the third one. What is fraction? If you can pass the first 8, 8 over 15, right? And this one is bigger than 2.5, right? 8 is bigger than half of 15. So this one is bigger than this one. And this is actually, if you divide by 3, this one is bigger than 83%. So you should be comfortable if you have 83%, because normally the passing threshold is 75%. Okay, so let's work on the first, well, the first 2 actually is not that right, because we have the, We are given only the first one. Okay, you would get the first the credit for the first test case, right? So there'll be 2 plus 1 over 15. This one is not enough. It's less than 75% divided by 3. I'm sorry. So you need to finish the task, the subtask here, right? Subtask 1, 2, 3, 4. So 1 and 2 should not be too bad. We're going to try each one. Try each one, see whether it can reach a level, right? So basically what we want to do is like this, bring down, okay? You have n numbers. Let me write in a, this way here. So the numbers are like this. So for each one, we have the H1, H2, the last one, HN here. So we're going to assume it can bring down to this level, say L here. We're going to try for each L. This L, right, should not be too big. L should be no more than the lowest value of the H1 through HN. If this L does not work, right, we're going to actually start from the lowest value of the n numbers, start from there. And then we're going to bring this number, this, right? So here, start from here. And then if this is one is not possible, try the next one. If it's not possible, try the next one. If at any point, if this is possible, then that should be the smallest one, right? Because if you start from this lowest value of H1 through HN, that's the highest L you can achieve. Because if you put it even higher, right, that's impossible because this number is less than this L. So you're going to start from this minimum value of all H values. And if it works, that's your answer. If it does not, just bring it down. So how many different values you can get, right? So that's the minimum of this array H. For each one, you're going to say, bring this down here, right? Working from the left, H1 minus this L. This one goes down, and this one also you have to go down. Right, you cut this one here, and this one also cut, right? If it's still taller than this L, you're going to cut further. So you're going to process each one until the last one. If the last one after cut all of them, right, is the same as L, you're good. If cutting cutting from here, right, the last one is not L, then you know, right, this one is not possible. So we're going to write this one by n iterations. So H at the most 1,000 here, actually 100. The first 8 subcases, right? Times n is at most 10.5. We can do it. Because it guarantees in each input, the sum of all the n's, right, should be less than or equal to 10.5. So this one is 10.7. 10.7 is less than 10.9. So we can finish the first 8, and then we should be able to get the passing threshold. Okay, let's try this. And we're going to improve this one, actually, make it faster and faster. Okay, so, okay, now the first one, you don't have to work. But the last version, I want you to work it together with me. So the first one, just watch. Okay, so I'm going to keep in mind this one, and I'm going to erase and just implement this idea. Okay, so going to here, drought 0. Okay, this is the current version. That's the brute force way, and we're going to do this is T, the number of sub test cases. Okay, you can the same thing, right? T goes from 0, T less than uppercase T, T plus plus. Again, this little t does lowercase t does not go into the calculation. Just run uppercase T times. So for each one, we're going to read n. So this is the H. I'm going to use uppercase H here. The minimum, how do you use this one here? I'll do the cost later. So cost should be, I'm going to start from the max value. Okay, but first I need to, I'm sorry, I did not have the minimum age should be, again, 100 here, oh, 1,000 here. Is it the case? Oh, could it be 10.9? Okay, let's do 10.9 here. Okay, for some of you, right, if you're not familiar with this one here, this underscore just help you to count how many zeros you have entered. Sometimes may be confusing. So if you put underscore, that will help you to count. I'm going to read the numbers here. So HJ should be in this one here, and I'm going to have the minimum value. So minimum should be math dot minimum and HJ here. All right, so now I'm going to have this one here, the level. Actually, I don't want to use level here, but I don't want to use the variable L because it's confusing with the integer 1. I'm going to do H0. That would be minimum here, and H0 should be big, then equal to 0, and H0 minus minus. So I want to bring all HJ down to H0, and we're going to find out the cost. Okay, so this would be the minimum cost. M cost. Okay, now here I'm going to do the cost. One cost, that's 0. Cost. Bring down here. So this is the cost to bring down of bringing all HJ down to H0. So here, J goes from 0, J plus 1 should be less than N here, J plus plus. Why J plus 1 less than N? Because if I work with J, I would do that for H at J plus 1. Right. So here, if HJ is big than H0, what I need to do is I need to bring down here. So the difference D is HJ minus H0 here. Now my cost should increase by D here. I don't want to do this one times 2, but later I'm going to do this times 2. Okay, at the very end, I'm going to do that one. So HJ now should be decreased by this D, and J plus 1 also should be decreased by this D. Okay, every time when I bring this HJ, so this is HJ, and this is HJ plus 1 here. This is H0. I want to bring everything down to this one, right? So this part is the difference. Difference is HJ minus H0 here. So this one goes down by D. This one also has to go down by D. So HJ is decreased by D. HJ plus 1 should also decrease by D here. That's why I want to make sure, right, J plus 1 is less than N. If normally, right, J goes from 0 J less than N. If J is N minus 1, J plus 1 will be N. That will make this out of bound error. Okay, so now if HJ is bigger, that's fine. What if HJ is low, equal to, that's fine, right? Actually, bigger than or equal to does not matter. But if this one is less than, so hj actually is less than h0, that means you have done something here. Let's see, this one is here. When you do next time if you do hj, right, you have to bring these guys down. But even you bring this down much, this is your new hj plus 1, this will be lower than h0, then that's bad. That means this h0 you cannot achieve, right? So in that case, you can just break. So cost would be just the max value and break. And after we finish this one here, we're going to say the minimal cost should be math.minimum here and cost. Oh, at the end, I did not try to have to work the last one. If you have done, this is at position n-2, and this is n-1, right? You have brought this down here, and this one still is above. You cannot have any more ways to bring this down, right? This one all to the left, if we can bring them down to h0, but the last one is not h0, then that's also not right. So here, if h n-1 is equal to h0, then we're going to try this one. Otherwise, you don't. Because if it's not, that cost is not eligible. But notice, right, I did something wrong, because well, not wrong. I've changed the value h. So probably I need to make a copy of this one here. Every time you do this, I want to make a copy. Make it another one. So h a j goes from 0, j less than n, j plus plus, and aj is just hj here. And now we're going to change this to a here. And this one should be a. Okay, so next time if I try a different h0, then I still have the correct array h. If you have done this modification, next time you try it will be different. All right, okay, so that is for the situations when n is small, when the value h is small. So that's basically the first 8 sub-test cases. The first 8 test cases, we should be able to get it. So let's try this one here and see whether this is the case. So if m cost is equal to integer dot max value, then we're going to print -1. Otherwise, just print m cost. Okay, let's try the sample input. Okay, add one more so that your output should be aligned to this one here. Okay. Okay, run it here. Oops. Oh, I did not do the ×2, right? So here, ×2. Run it again. Okay, so 14. Oh, this mistake here. The second one actually should be 16. Let's see why. This one is the second one. Let's see. 464, 464. And why it's not giving us the right answer? Oh, this one is A. Okay, make sure this is correct. Okay, do it one more time. Okay, now 14, 16, -1, 3 times. That is right. Okay, let's see how many cases will pass. Okay, so here. Route 0. Okay, the first 8, now 9 does not work. Why? It will run out of time. Case 9, the input, the values right here, the HI would go too high and this will not finish. So I'm going to terminate. Okay, just check. Okay, so the first 8 does work. Okay, as we said, right, we could get the first 8 cases and that will be enough to get the promotion. Even though you don't get the perfect score, but you still would be able to pass the 750 threshold. Okay, maybe from here, you can learn something, right? In a contest, especially toward the end, you have worked so hard in the first 3 hours, the last hour, or maybe the last 30 minutes, if you cannot get a perfect score for all the 3 questions, but to pass, just look at the description or the scoring part. Try to get as many sub-test cases as possible, and then you should be able to.
Like there's 4 hours to a test?
Yes, there are 4 hours.
I always thought it was 3.
No, actually, when you do that right, you're going to have a timer at the upper right corner. It tells you right how many more minutes or how many hours you have left. Okay, so next time you should have the experience, right? Actually, for the US Open round, the time is 5 hours. Okay, so this one is to pass the first 8. And how do you pass all the test cases? Actually, there's one more step. If you notice, for the going from 9 to 11, 3 more cases, actually you can try this one. N is even. Why N is even could be special. If N is even, you can always put them into pairs, right? These 2 together, these 2 together, these 2 together. If N is even, you can put them into the pairs. Okay, so the pairs, if you don't have to try all of them, look at this one here at the very end. So you bring them down here, no matter what you do, right? If you say, I've tried to this minimum value, mn here, mn is the smallest value of all the numbers h1 through hn. I try to bring down to mn, it does not work. I'm trying to do this one mn minus 1 or h0, right? Start from here and h0 minus 1 and all the way down to 0. For n to be even here, try this one here. If it does not work, you don't have to try others. Why? If this one does not work, there is no way below here it will work. Why? Because if this one works, right, just bring them to the same. right? Every time you just bring up by the same, and then if you can reach this level here, you can also reach this level here. So just try the top one, then you're going to, that's enough. The only one height H0 you're going to check when n is even. So you can get 3 more cases. So from 2 to 8, I mean from 1 through 8, and also 9, 11, and 9, 10, 11. So there'll be 3 more, and 11 out of 15. That will make you boost your case, right? So this will make it more than 90%. Okay, so next we're going to show a method that will actually finish all the test cases, and actually the complexity or the number of calculations actually is not too bad. Okay, so listen, and I'm going to use this board here. Now, suppose I have the array age going from 1 all the way to hn here, or start from, does not matter. Okay, I'm going to go from h0 through hn minus 1. So the first round, I'm going to h0, h1, h2. So using hi and hi plus 1 here, I goes from 0 all the way through n minus 2. If hi plus 1 is higher, I'm going to bring it down. Actually, let me change the way to say it. I'm going to represent it in this way. This is hi, this is hi plus 1. If hi is bigger than hi minus 1 here, so I'm going to do I goes from 1 all the way to the end. If hi is bigger than hi minus 1 here, then I need to bring down, right? So this is hi minus 1. This is hi here. So I need to cut this off. But how do you cut? You're going to bring this down together, right? This D would be here and also would be here. So I'm going to say align hi to hi minus 1. So this is if hi is taller than hi minus 1. Then I'm going to adjust hi and adjust hi minus 1. Otherwise, if hi is less than hi plus 1, so it could be like this. Hi is here, and this is I minus 1. And this is hi. It is less than this one here. I'm going to leave it like this. I'm going to keep it. But I don't allow this hi is bigger than hi minus 1. So I'm going to say keep it or do nothing. Only when this one is bigger than or equal to, right? Or less than or equal to, does not matter. So only when this one is bigger, I'm going to cut it off. So to align all of this the same as the previous one, if it's taller or if it's lower than the previous one, that's fine. So I would have, after I process this one from 1 through n minus 2. Okay, look at this one, right? This I cannot be 0 because I'm going to check I minus 1. This I cannot be n minus 1 because I need to also, if I want to bring down, right, I need to do this hi plus 1 here. All right, so once I have finished this one here, I would have an array like this one, the same, that's fine. Going down, that's fine. And then this one, you can keep the same, that's fine, but you cannot go up. Why? If this I is taller than I minus 1, I'm going to also bring down. So I can keep the same, that's okay. Bring down, that's fine. So I'm going to have a updated, so this is the H array. After this process, right, it would be something like this one. It would be non-increasing. So could be the same, could go down, but cannot go up. Okay, good. Okay. So if at the end, right, I've done this one here, the last one is up. There is now nobody to help here, right? If that's the case, then you know it's impossible. It's impossible to bring down. Why? If you want to bring these guys down, right, you're going to say bring down, bring down, bring down, right? That will affect these guys to bring down. So that will make these guys even down further. There is no way to make this down. Or you say you want to go from here, right? You want to bring this. Well, there's no way. If you say bring this down here, then this will go down further. Okay, so if the last one is taller than this, so n minus 1 is taller than the one at n minus 2, it's impossible to bring all the numbers to the same level. Okay, this one does not, right? What if this one is like here, right? How do you know this one is possible? Don't worry, we're going to do another way. We're going to, we did from the left to right. Next time we're going to do on the same operation from right to left. So if this one is bigger than this one here, I'm going to bring this down. If it's same, leave it right. So this one is taller than this one, we're going to bring this down here. And this one also should be brought down because they always work in pairs. Okay, when you go from right to left, you don't have this going down anymore, right? So it can only go up in this way. So always you're going to bring down further. So if it's at the beginning, at the end, right? If say everybody is at the same level, that's fine. You get the answer, right? If the same, if this one is taller or lower, you know, it's impossible. Oh, actually, this is impossible. If it's taller, you cannot do it. Only when the last one is the same as this one here, then you say, yeah, it's good. Okay, so we're going to go this one, left to right and then right to left. Okay, the number of operations, right? You go from left to right, you're going to do n iterations. Each one you're going to do a constant number of operations, maybe 5, maybe 10, does not matter. So 10 times n. Another round going from right to left, that's also say 10 times 9. So 20 times n. N is 10, 5. So this one is 10, 2 times 10 to the power 2 times 10 to the power 6. This one is still less than 10, 9. So it does not matter how high this hi could be. All right, okay, so let me go through the this one. It's already 40. So I'm going to go through the answers already I have here and the drought. Okay, just go through. T, that's the number of the test cases. T, T0, T, lowercase t goes from 0 less than t here. The same as what I did this one, right? Roughly the same thing. N is the number of the integers or the hay bales, or the counts actually. H is the original array. Now I'm going to do this one, sweep from the left to the right. Try to bring the adjacent hi to be aligned with hi minus 1. And if this one is level, if all the values of h, they're the same, that's it. That's the answer. We're going to print the answer there. And we're going to keep this one as a long integer because even though each one is in the range from 0 through billion, right? That's within the range of the integers. But if you add this up and down a couple of times, then this could go up out of the range of integers. So I'm going to make this one long integer. If you sweep from the right to the left, the h is already aligned, I mean level, then that's the answer. Otherwise, this array h is not level yet. We're going to sweep left from the right to the left. And the cost would be increased to answer here. Now, if this new array H after sweeping from right to left, it's level, we're going to say that's the minimal answer, the minimum cost. If it's not level, then this answer should be -1. It's impossible to bring it to the same height. Now we're going to do the sweep right and sweep left. Okay, sweep right, basically the idea I just explained. And that's number of the integers in this array H. Sum the cost initially that's 0. Now we'll go from 1 through n-2 here. J goes from 0, j less than or equal to n-2. If hj is bigger than the one before, we're going to bring down hj to this one to align with the one before on the left. So the difference is this one here. Sum should be increased by this d. Don't worry, right? Eventually we're going to multiply this to sum. So hj would decrease by d, hj plus 1 should also decrease by d. So that's what we can do, right? Sweep from the left to the right. Every time if hj is bigger than the one before, we're going to bring down hj and hj plus 1 by this difference d. Okay, don't worry about this one will be be negative, right? If this one is positive, then the difference is always positive. So don't worry about the negative numbers. Okay, so that's the sweep from left to right. And then we're going to sweep from right to left. The same array, the same m, I mean, roughly the same idea. And if we want to write, we can just say, rotate the array H, and you can call this sweep R. The same thing, but actually just change this one. So j goes from n-2. Here we start from 1 and less than the biggest value, right? We could say bigger than the smallest value, and then each time j would decrease by 1. If this time hj is bigger than the one, again, previously, we're going to decrease hj and hj minus 1 by this difference. Again, times the sum by 2, because each time we're going to bring the operation to the pair, so times 2. So sweep left, sweep right would work very similarly. Okay, you can optimize afterwards, as I said, right? Just say change the array, flip it, and then sweep left would be the same as sweep right after you're done, and then sweep back, flip back. Okay, so that's another way to reuse the code. The part of the code, right? This loop, you notice, right? This part here, 50 to 57, and then the part from 66 to 71 here, that's basically the same thing. Oh, I'm sorry. So 35 to 42, and then 50 to 57, the same thing. Now, another function that we used, right, is to say whether the array is level. So we're going to check whether all the numbers are the same, but make sure, right, this one is non-negative. If it's bigger than 0, that's fine. If the first number is negative, then you're going to report false. Okay, and then if this one is non-negative, and then we're going to check each one if it's the same as the previous one. If any one is not, then you're going to report false. Otherwise, you're going to report true. Okay, so if you do this one, then this will make the life much faster. So here, I'm going to do drought. Right, so from the cases from 9 all the way through 15 actually does not hurt. It will be the same. All right. Okay. So I've shown you here the 3 questions and also the experience of taking the USACO contest, especially at the lower level. Try some brute force ideas. If it works, perfect. If it does not work, try to improve it. And at any time, you know your score, right? If you know you're at the boundary of say close to 750, or you're already over 750, then try to add a few more cases to just be careful. Sometimes the threshold may go up. This does occur. Sometimes the threshold could be 800, but I've never seen any time the threshold is higher than 850. So 85% is the highest I've ever seen. It only occurred once. Most of the time, the threshold should be 75%. So just calculate your score. And if you are over that 75 or even 800, 80%, right, then you should be comfortable. Don't strive to pass all the test cases unless you have them ready. You say, I have already 720, 730 right there, and I still have time. You want to work on it, that's fine. Always keep the level, the submission version that right, that will give you the highest version, the highest score, because in the last 5 minutes, right, you may submit another one and then the score actually went down. So always bring it back. Okay, actually, when you do the submission, USACO would keep all the versions. Actually, it will be a stack. The first submission would be at the bottom, and the second one, third one, and so forth. So keep that version number, version 5, version 6, that will give you the highest score in the last minute or two. If you did not make it higher, right, just bring back that version. So USACO will always count your last submission. Okay, so let me okay, there's questions. How do you make sure the last one isn't going up? Oh, I did not check here, right? I just check after I have swept here. I would check if it's level. If the array is all the elements, right, are the same. If it's not, I'm going to do one more round. Again, once I finish, I'm going to check whether the array is level. If it is, yes. If it's not, report -1. What if the value deep below 0? Yeah, that's what I checked here, right? If I say, if this value is negative, then you don't have to try further. It's already false. Okay, hope that answers your question, John. And Kathy's question, can you improve your score during the contest on purpose, right? Yes, okay. So sometimes if you have, say, very close to 75%, right? Just try your best. Make a few changes, and sometimes would be heuristics. Try to improve your score to pass one more case.
Oh yeah, and try debugging.
Of course, debugging, yeah. Well, the hard part for debugging is you don't know the input, you don't know the output.
No,
So
like when you're debugging, like use the debug mode.
Yes, true. Okay, so the moral for the past 2 rounds of season 2022, right, is actually don't be afraid. Even though the numbers may be scary at the first glance, but whenever that is the case, look down and then the scoring part, right? The subtask 1, 2, 3, 4. So you still have the room to pass. It's not the case. All of them would be, say, n would go to 10.5 and then the numbers will go all to 10.9. That's not the case. So just try your best. Remember, right? To pass, you just need to beat the threshold. If you beat by, say, the perfect score or beat by just the threshold, it's the same. The next round, you're all in the same level. I mean, silver, right? So, but after the contest, you should summarize and try to learn what can I do in the future so that I can use the time in a more effective way, and also don't go panic. Yeah, okay. So I'm sorry. When I am this mode, then I'll keep talking. Okay, so this is over, and hope if the techniques right, sometimes not so comfortable, just practice. And in the spring semester, we're going to do a lot of these, put you guys more hands on. And then if you have any question in the class and off and also off class, please ask me. All right. Okay. I'll stop here. I'll see you guys.
Thanks for class.
Sure. You're welcome.
See you.
Bye.